Hi, this is Amita Sharma. In this video, we'll learn to use SQL statements to query and display data from multiple tables using joins. We'll learn to use subqueries when the condition is unknown. We'll learn to use the group functions to aggregate the data, and we'll also learn to use the set operators. So let's proceed and let's see how to use the joins when working with the multiple tables. So sometimes we need to use data from more than one table. So here in this example in the slide, here you can see the report, the final table, it displays the data from two separate tables. And the employee IDs exist in the employees table, whereas the job IDs exist in both the employees and the jobs table. Okay, so job title here, it's there in the jobs table. So to produce the report, we need to link the employees and the jobs table, and then only you can access data from both of them, as here you can see in the resultant table. Now here we are going to see how to get the data from multiple tables with the help of join. So what is join? Join is a query that combines rows from two or more tables or views. And here the Oracle database, it performs a join whenever multiple tables appear in the from clause of the query. And under the joins, we are going to study about all these different types of joins that we have. We have the inner join, which has natural join, join with using clause, join with the on clause, as well as we'll be discussing about the outer joins and the cross joins. So coming to the syntax of the join, here in the syntax you can see we have select table1 dot column. So here table1 dot column, table2 dot column, this denotes the table and the column from which the data is retrieved. Then we have this keyword natural join, which joins two tables based on the same column name. Then we have join table2 using clause with column name, which performs an equi-join based on this column name. Then we have join table2 on table1 dot column name is equal to table2 dot column name, which performs an equi-join based on the condition in the on clause. We have these left, right, full outer join, which is used to perform the outer joins. And then we have this another type of join, which is cross join, which returns a Cartesian product from the two tables. So we are going to study about all these joins one by one, and we'll see how it works when we need to retrieve data from multiple tables. So this is the syntax for using the join. So here we'll be talking about the inner join. That is, we'll be discussing about the natural join, the join with using and the on clause. Now, how to create the natural joins? We can join tables automatically based on the columns in the two tables that have matching data types and names. And this can be done using the natural joins. So here this join can happen on only those columns that have the same names and the data types in both the tables. That is in both table 1 and table 2, if we consider here this example. So here if the columns have the same name in both these tables but different data types, then in that case this natural join clause will cause an error. So the condition here for using the natural join is that the common column should have the same name and the same data type. And here in the natural join, the column is being selected by default. the user doesn't specify any column for performing the join. So this is one type of inner join. Now here, let's see, here in this example, here we have two tables. One is the jobs table and another one is the employees table. So here if we see this resultant table, here we have this job ID column, which is the only column of the same name in both the employees and the jobs table. If other columns or apart from this job ID, if other common columns were present, then join would have used them all. So here, this is the simple example where we are extracting the information from both the tables, employees and jobs, on the basis of the common column, that is the job ID. Okay, so this is how we use the natural join. Now here, if we need to apply some restriction on this result set, so for here you can use the natural join with the where clause. So if we have to apply that restriction on a natural join, that can be implemented just by using the where clause here. Next, we have creating joins with the using clause. In case of natural joins, they use all columns with the matching names and data types to join the tables. Here, we'll be using the using clause to specify only those columns that should be used for an equi-join. So here explicitly we can mention the column name for matching the tables. So here if we say equi-join actually is a join containing an equality operator, and natural join is a type of equi-join. Okay, so let's see here one example based on this. So here we have these two tables, employees and departments. To find out the employees department name from the departments table, we compare the value in the department ID column in the employees table with the department ID column with the in the departments table. So here, this relationship between the employees and the departments table is an equi-join. That is, values in the department ID column in both the tables must be equal. Okay, and here, this type of join involves primary and the foreign key complement. So this is how we join the tables. Okay, so let's come to the example here. Here in this example, you can see we have the department ID column as we had seen in the previous slide, the common column that we have in both these tables. So here the department ID column in the employees and the departments tables are joined. Okay, and we have the location ID of the department where the employee works, that would be shown here in the output table. Okay, so here we have this employee ID and the last name columns which belongs to the employees table, and we have the location ID and the department ID which is common to both the tables. So on the basis of this common column, we can extract these columns from both the tables. So this is how we use the using clause along with the common column name on the basis of which we want to join and we want to extract the information. We use that particular column with the using clause. Now let's see some ambiguous column names, how to work with these ambiguous column names, how to work with these ambiguity state, and what would be the solutions for not having these ambiguous column names. So when joining two or more tables, we need to qualify the names of the columns with the table name to avoid ambiguity. So without the table prefixes, if we consider the same example that was, let me just move back. Let's see the same example here. If we don't have the table prefixes, the department ID column that we are extracting here in the select list could be from either the department's table or from the employees table. So here it's necessary to add the table prefix to execute your query. If there are no common column names between the two tables, then in that case, there is no need to qualify the columns. Okay, so basically we use these table prefixes to increase the speed of parsing of the statement, because here you tell the Oracle server exactly where to find the columns. Though the qualifying column names with the table names can be time consuming. Okay, and if the table names are lengthy, then it would be obviously more time consuming. So instead of that, what you can do, you can use the table aliases. Just like the column alias give a column another name, which gives a column another name. Similarly, you can have a table alias which gives a table another name. Okay, so here these table aliases help to keep the SQL code smaller, therefore it uses less memory. So here, if we take the same example here, you can have, let me just, you can have the employee table, the alias for the employee table you can take here, and here it can be given the alias name as E. Similarly here, for the departments table, you can use the alias D. Okay, so this is how, when you use the table aliases, it helps to keep the SQL code smaller, and obviously it is going to take less of memory. Now there are a few things that you have to keep in your mind whenever you take the table alias. It can be up to 30 characters in length. Okay, but whenever you are using the table aliases, just keep the purpose of using the aliases in mind, and it would be better if you go with the short aliases instead of using the longer ones. Clear? If you are using the table alias for any particular table name in the from clause, then the table alias must be substituted for the table name throughout the select statement in a query. So once you have taken the alias, throughout the scope of the SQL query, you will be using the same aliases. And the aliases that you take, it should be meaningful. And the scope, as I have already told you, that the scope, or it is valid for only the current select statement. Okay, so here let's see how to work with the table aliases with the help of the example. Here in this example, you can see we have the tables locations where we have taken the alias as L, and we have the other table departments for which we have taken the alias D. So here we are combining both these tables to extract the information city and the department name. City is the column name that is there in locations, and the department name is the column which is present there in the departments table. Okay. Now here, one thing you have to keep in your mind, when you are using the aliases with the using clause, that time you cannot qualify a column that is used in the using clause itself. As you can see here, everywhere with the column name, we had taken the alias, except the column that is being used with the using clause. Okay. So here, if you take the alias along with the location ID here with the using clause, that time it will give you an error which says column part of using clause cannot have qualifier. Okay. So this is something that you have to keep in your mind when you use the using clause. Now let's see how to use the on clause. Now the join condition for the natural join is basically an equi-join for all the columns with the same name. So whatever the natural join or the join using the using clause we had studied till now, in these joins we had used the column which had the same name. Okay. Now here, when you are using the on clause, here you can specify any column that you want to join. Okay. And you use the on clause to specify a join condition. With this, you can specify the join conditions separate from any search or filter conditions in the where clause. And here, when you use the on clause, it makes the code easy to comprehend, easy to understand. So let's see with the help of the example how the on clause would be used for joining the tables. So here in this example, the department ID, columns in the employees and the departments table are joined using the on clause. Okay. Now you see the way it has been taken. Here you have taken the aliases for both the tables and you are extracting these columns as per the aliases from employees and the departments. Okay. Now here what the condition says, whenever a department ID in the employees table equals a department ID in the departments table, the row is returned. And here you will see that here the table alias is being used and it is necessary to qualify the matching column names. Okay. One more thing here you have to keep in your mind that if we have the same column name, it's well and good. We use the same column name and same data type in natural join, which was taken by default. We had taken the same column name, maybe with different data type using the using clause. Now here with the on clause, you can have the same column name, same data type, same column name, different data type, as well as you can also use the on clause to join the columns that have different names. Okay. So here it depends what is the requirement, whether you want equi-join or non-equi-join. So both these conditions, both these operators can be used here with the on clause. Now you can see here the parentheses we had taken specifically. Here these parentheses can be the optional. Without the parentheses also, this join condition will work. Okay. So let's see more about the on clause. Here we had two tables. Now let's see how this clause works with three tables. Now we have here in this example, 3 tables, the employees, the departments, and the locations. Since we have 3 tables here, so we are creating here 3-way join. So what is this 3-way join? It is a join of 3 tables. So here the first join, as you can see, is performed on the employees and the departments table. So the first join, it references the columns from the employees and the departments table. But here at this point of time, it cannot reference the locations table. So the second join condition can reference columns from all the 3 tables, including the locations. Okay, so here as you can see, we have department ID and the common is the location ID. So here, when you combine employees and the departments, what you get? You get employee ID and the department name. And when you combine the location ID, that time what you get? You get your city column here. So here, since we are having the same column name, so here even this example, when you try to use the using clause, with the using clause also, it will give you the same result as we are working with the same column name, the department ID and the location ID. Okay. Now, again here, if you want to apply some additional conditions, if you want to impose some restriction, so how it would be done? Here, just like in other joins, we impose the condition, same way here, we can apply conditions to the join. Here in this example, you can see that the join on the employees and the departments table, and here we have the condition which imposes the restriction, that is, it will display only employees who have a manager ID of 149. So to add this additional condition on the on clause, you can use either the and clause or you can use the where clause. Okay. So here both the queries here will give you the same output. So for imposing condition onto the join, you can use either the and clause or you can use the where clause. Okay. So this is all about your on join. Sometimes you need to join a table to itself. Like here, if we take this example, we have the table employees, which is used in 2 perspectives. And here, if we want to know the name of each employee's manager, then in that case, we need to join the employees table to itself, or that is to perform a self join. Sometimes you need to join a table to itself. Now let us consider here this example. Suppose we have to find the name of each employee's manager. So here you need to join the employees table to itself or perform a self join. Let's take an example. For example, here, to find the name of Ernest's manager, we need to first find the Ernest in the employees table by looking here at the last name column. Then we have to find the manager number for Ernest by looking at the manager ID column. And here Ernest's manager ID is 103. Then we have to find the name of the manager with the employee ID 103 by looking at the last column. Now here 103 has the name, the last name as Hanald, and Hanald's employee number is 103. So Hanald here is Ernest's manager. Okay, now here in this process, we look in the table twice. The same table we are looking from two different perspectives. The first time we look here in the table to find the Ernest in the last name column and the manager ID value of 103. The second time we look in the employee ID column to find 103 and the last name column to find 100. So here, let's see how this would be done and how it would be written. Here we have used the on clause, and the on clause is used to join the columns that have different names. So here we have manager ID and employee ID, two different columns within the same table. This can be in the same table, even in the different tables. But here we are talking about self join, so we'll be talking only about the same table. So here in this example, it shows the self join of the employees table based on the employee ID and the manager ID columns. So here you can see we had taken the alias for the employees table. We have taken two aliases. One is the worker and the second alias is manager for the same table name, because joining happens for two or more than two tables. So here we need to have minimum two tables. So that is why we have taken the same table with two different aliases. So here, this is how we find out the manager ID for any of the employee ID. And here this is done with the same table. So this is a type of self join. Now let's move on to the another type of join, which is non-equi-join. Till here we have seen all the join conditions which had equi-join. Now let's see what is this non-equi-join. Non-equi-join, it's a join condition just like your equi-join. Here it contains something other than the equality operator. So here in this example, you can see the relationship between the employees and the job grades table. Here, this is an example of non-equi-join. Why? Because the salary column in the employees table ranges between the values in the lowest salary and the highest salary columns of the job grades table. Therefore, each employee can be graded based on their salary. So the relationship is obtained using an operator other than the equality operator here. That is why this is an example of non-equi-join. So let us just see this example with the help of a query. Now here in this example, we create a non-equi-join. Okay. And this non-equi-join condition is used to evaluate the employee's salary grade level, and the last name. And here, as per this query, the salary must be in between any pair of the low and the high salary ranges. Okay. Now here, you will see that all the employees exactly appear once when this query is executed. No employee is repeated in the list. Why? Because none of the rows in the job grades, in the column job grades table, contains the grades that overlap. Okay, so here you will see we have 1000 to 2999, 3000 to 5999. So nowhere there is overlapping taking place. So the salary value of any of the employee will lie only in between the lowest salary range and the highest salary values of one of the rows in the salary grade table. Okay. The second reason is all of the employees' salaries lie within the limits provided by the job grades table. That is, no employee earns less than the lowest value contained in the lowest salary column or more than the highest value contained in the highest salary column. Okay, so here you can see the condition that has been used here is between and operator. You can use other operators also. Instead of lowest, you could have used less than equal to. Instead of highest, you could have used greater than equal to. So here it's just a matter of simplicity, logical simplicity or convenience. So either of these operators will work perfectly and it will give the same result. So this is the example of your non-equi join. Okay. Now let's move on to the another type of join, that is the outer joins. Till now we have been talking about the joins which works on the basis of the matching columns. So we have all the rows which are retrieved by matching the column. So the rows are the matching records. Okay. Now what if a row does not satisfy a join condition? Then in that case, if it is an inner join, the row will not appear in the query result. Now here in this example, if we consider here, a simple equi-join condition is used on the employees and the departments table to return the result on the right, this one. Okay. Now here, if you see what the result contains, the result does not contain the department ID number 190 because there are no employees with that department ID recorded in the employees table. So nowhere you will find 190 here in this table. Okay. Even the employee with the last name of Grant will not be seen because this employee has not been assigned a department ID. Okay, so to return the department record that does not have any employees or the employee that does not have an assigned department, for that you can use the outer joins. Okay, now let us understand more with context of inner join. Here, as you can see, these are the differences in between the inner and the outer joins. Okay, so joining tables with the natural join using or on clause results into the inner join, and any unmatched rows are not displayed in the output in this case. Now to return the unmatched rows, we can use an outer join. So the join, what is the outer join? The outer join is the join that returns all rows that satisfy the join condition and also returns some or all of those rows from one table for which no rows from the other table satisfy the join condition. So we have three types of outer joins. We have the left outer join, we have the right outer join, as well as we have the full outer join. And this is the join which is only supported by the Oracle. In MySQL, we don't have this join condition, so it does not support full outer join. Okay, so let's see through the example how we are going to use these different types of outer joins. As you can see here in this query, it is retrieving all the rows of the employees table, and here this employees table is at the left, and from the departments table which is placed at the right. So here we are retrieving the information, the last name, the department number, and the department name. Okay. Now here what this query will do, since it is a left outer join, it will retrieve all rows from the employees table, which is the left table, even if there is no match in the departments table. So first it will find out the match in between the employees and the departments. And after that, if there is no match there in the employees table, those unmatched record will also be returned here in the result set. So basically the left outer join, this will return all the rows that matches between the two tables on the given condition, and it also returns the unmatched rows of the left table. Okay, the table that is mentioned first here in the SQL statement, and the rest of the columns, it will just assign null to those columns because it is left outer join. Same way, here we have the right outer join. As you can see here, we have right outer join. We have the same query written again, but only the join condition has been changed. So here this query will retrieve all the rows in the departments table, which is the table at the right. Even if there is no match here in the employees table, then also it is going to display that in the result set. So what this right outer join does, it will return all the rows that matches between the two tables on the given condition, and also returns the unmatched rows on the right table. Okay, so here you can see in this example what you have last name as null, whereas you have the department number and the department name. It does not have any matching record here from the employees table, but then also it has taken all the leftover unmatched rows here in the results set. Okay, same way same way we have one more join, the third type of join under the outer join, that is full outer join. By the name itself, you will be able to understand that this full outer join is a combination of left outer and right outer. Okay, so what it is going to do, this query will retrieve all the rows from the employees table, even if there is no match in the departments table. It also retrieve all the rows in the departments table, even if there is no match in the employees table. So here the full outer join will return all the rows that match between the tables, two tables on the given join condition, and it also returns the unmatched. Okay, it also returns the unmatched rows of both the tables. So this is what we mean by the full outer join. Let's move on to the next type of join, that is the cross join, which helps in creating the Cartesian product. Now, what is this Cartesian product? Cartesian product, actually it generates a large number of rows, and here the result is really useful. Why? Because generally we don't need to have all the combinations of rows or one table with the combinations of rows of another table, and Cartesian products are useful for some tests when you need to generate a large number of rows to simulate a reasonable amount of data. Okay, so here it's always better to include a valid join condition. Otherwise, it will give you all the combination of rows of both the tables. So here you can see how the Cartesian product generates the result set if there is no condition taken. Here you can see in this example, we have the employees table which has 20 rows and the departments table which has 8 rows. So when you perform a Cartesian product on these two tables, what you have, you get a resultant table where you have all these rows combined with the rows of the departments table. So in total 20 into 8, you will be having a collection of 160 rows, and this is what is your Cartesian product. Since there was no join condition specified here, so that is why all 20 rows are joined with all 8 rows of the departments table. Now here what is the join that is used for producing the Cartesian product? It's a cross join. Okay, so here it's a good practice to explicitly state cross join in your select statement when you want to create a Cartesian product. Okay, so here you can see we have extracted the last name and the department name, where we have used cross join in between the two tables, that is the employees and the department. So this is how you get the combination of both the tables, that is employees and the departments. So that's all about all the joins. So here in this video we have learned multiple ways to join the tables. We studied about different types of joins like the equi-joins, the non-equi-joins, outer joins, self-joins, cross-joins, natural joins, full outer joins, and we also discussed about the Cartesian products and the table aliases that could be used while joining the tables. So that's all in this video. Thank you and have a nice day.